So new stuff today is Chapter 7, Section 4. It's division properties of exponents. So division properties of exponents. So before, it was always like a x to the 5th times x to the 7th, or x to the 5th to the 7th, something like that. Now we're going to, instead of doing multiplication, we're going to be doing division, is what it boils down to. I had the trick in the yesterday's notes about how to remember what to do, and we listed what math operations make things bigger from strongest to weakest, and we had like exponents, multiplication, division, right? So we had like exponents being most powerful, multiplication, then addition, and you always do one step lower the exponents, right? So now if we're looking at what math operations typically make the answer smaller, you have which two? Subtraction and division. And the more powerful the two is division. So you can remember these the same way, that if you say division, the answers are typically smaller. Subtraction, the answers are typically smaller. Division's the strongest. You could still do that same one step lower with the exponents. So one step lower the exponents. In other words, and I'll write an example, and then we can actually do like the little box with the official rule in it. But if I were to have like a 5 to the 5th, 5 to the 5th, sure, over a 5 to the 3rd, what do I do to my exponents there? That should end up being 5 to the 2nd. Or I could write it out 5 minus 2, so a 5 minus 3, so a 5 squared. And if you want to like try to think about it logically, my 5 to the 5th is going to be 5 5s all multiplied together, right? My 5 to the 3rd is 5 times 5 times 5. Well, since it's all multiplication, we can reduce. We could cancel that one and that one. We could cancel this one and this one, cancel this one, this one. So we're just left with the 5 squared, right? So hopefully it kind of makes sense logically. If you get to a quiz or test and you're like, oh, what is it? Just figure it out. So if you have a b to the m over b to the n, that's going to equal b to the m minus n. So that's kind of the first rule. If you want to write the name, it's the quotient of powers. Quotient means division. We have two things that have powers. So that's the quotient of powers. I probably wouldn't bother writing it if I were you. I feel guilty not writing it as a teacher. It's the quotient of powers. The second one is going to be real similar to what we had before. It's the power of a quotient. And again, I'd probably skip the title if I were you. The power of a quotient. And this one I'm guessing just based off what we did yesterday. If we have a fraction like a over b, and we have all that to the m, does the m apply to the a, the b, or both? Both. So that becomes a to the m over b to the m. So that's that power of a fraction, or power of a quotient. Seem okay? Yeah. So the next step is really just give you some examples. I want to hit a scientific notation thing as my 5th example. You could write them. I hope to go pretty quickly. So in some respects, if you can't keep up writing it, you might want to just kind of sit back and watch. But these are things that typically I've seen people mess up on in the past. 5 to the 6th over 5 squared is 5 to the 4th. And then you could punch that into a calculator if you wanted to and get 625. I suppose if we're simplifying it for real, it'd be 625. It's on that index card I passed out, and you get better at it. So I can't do that with all of them. If I have a 3 to the 3rd over 3 to the 5th, this is one I didn't really prepare you for. 3 to the negative 2, which what is 3 to the negative 2? 1 over 3 squared, or 1 over 3 to the 2nd, which is the same as 1 over 9. Now, logically, if you want to try to think about that, and I wouldn't write this here down below, but does that make sense? Well, in the numerator, I have 3 times 3 times 3. In the denominator, I have 3 times 3 times 3 times 3 times 3. So as we start canceling things out, those two can cancel, those two. I'm left with a 3 squared down below, right? The extra 3 times 3 in the denominator. The big thing is this. We had the property where when you get something like that, you subtract the exponents. When you subtract the exponents, the answer always starts in the numerator. So when I get that 3 to the negative 2, it's 3 to the negative 2 in the numerator. The negative then means we move it. Is that fair?
Yeah.
So whenever you're subtracting exponents, the answer always starts in the numerator. All right, another example. So now we'll start throwing all kinds of, let's see if I labeled my examples. Example 3, if you want to label it, have a x to the 4th times y to the 8th over, in parentheses, x times y, and all that is to the 5th. Some people will try to do this all in one bloop. I'd encourage you to take a couple steps. So what would be one first step we could do? What could you do to make it a little bit more simplified? Let's look at the denominator. What can we do to the denominator?
X to the 5th times y.
Perfect, love it. So x to the 5th times y to the 5th. That 5 applies to the x and the y. Agreed? Okay. Then from here now, what do you want to do with your numbers? X to the negative 1, y to the 3rd. And the final answer then is going to be y to the 3rd over x. Technically it's x to the 1, but I wouldn't write the 1 because it's not simplified if you have the 1 in there because you don't need it, but that's your final answer. Here's where I feel like I should teach it this way. This should kind of be your default way if you, come back to this if I'm confusing you. But here's what I do, quite honestly, to kind of skip this middle step here. I look at my x's. There's more in the numerator or denominator? Denominator. How many more in the denominator? So when they cancel out, you're going to end up with 1 in the denominator. So there's 1 extra there. Then when I look at my y's, I have, more in the numerator. How many more are there?
3.
So you end up with 3 of them, well, y to the 3rd in the numerator. I just think that's way faster. But if that messes you up, then do your little subtraction, and then do you have to move it or not, and so on. But good? That makes sense to everybody? It's just way nicer. Okay. 2 more examples. Actually, maybe 3. But here I have, in parentheses, a 3x to the 4th over, still in parentheses, 5yz squared to the 3rd. And part of the reason for giving you some just ugly, awful things is to just kind of show you can do it. Yuck. That fits ugly and awful. If we look just at the numerator, does my 3 in the exponent, does that apply to the 3, the x to the 4th, or both? Both. So you're going to get a 3 to the 3rd and an x to the 4th to the 3rd. So I'm going to write it in a couple steps, but I probably would just do it in one step if you guys weren't watching. But it kind of becomes that, right? 3 to the 3rd is 3 times 3 times 3. 3 times 3 is 9. 9 times 3? 27. So we have a 27 times x to the...
4.
Is it 4 plus 3 or 4 times 3? 12. Yep. Because it's an exponent to an exponent, so what's one step weaker than exponent? It's multiply. All right, then in my denominator, does the 3 here, does that apply to the 5, the y, the z, a combination? All of them? None of them? Yep, all of them. So a 5 to the 3rd, and again, I'd probably skip this middle step, but that's the same as 5 to the 3rd, a y to the 3rd, and a z squared to the 3rd. But if your brain will do it all in one step, do it. 5 times 5 is 25, so think of like a quarter, 25 cents. Yep. 5 quarters is 125. So 125, and then I have my y to the 3rd and a z to the 6th. Z to the 6th. So now we're there. And then, can I do anything with any of my letters? X, Y, and Z, can we reduce? No, because they're all different. If we had an x in the numerator and denominator, you could. 27 over 125, shouldn't be able to reduce it, right? Nope. So they're not both even. You can't divide this by 3 because 1 plus 2 plus 5 is 8. You guys remember that trick? Add them up. If that's divisible by 3, it's divisible by 3. So it's not divisible by 5 in the numerator. So we're probably done then. So that should be our answer. All right, scientific notation. So example 5, if we're actually writing those. I'm going to say 2 times 10 to the 5th. I'm going to write it in kind of a weird way, though. So 2 times 10 to the 5th divided by 5 times 10 to the 2nd.
Is the times like actual times?
Yep. So this is just supposed to be scientific notation. The point of the green is when I have this 2 times 10 to the 5th, do you agree I could put the little like exponent symbol right there too? Maybe let me write this as, well, okay. Here's the point. What's the point of the green in there? Your calculator should have a button that says EE on it. When it shows up on the screen, it just shows up as an E. If you have a Casio, it should be like an EXP button instead of an EE. But this is Texas Instruments and I think the newer Casios. This in here in green means it includes that times 10 and the exponent key, and it puts the number in parentheses. So say you want to type in this whole thing here into your calculator. What you should be able to do is do a 2, then hit that little EE key, and you'll get like a E showing up on your screen, and then a 5. And then divided by a 5, then that EE key, and then a 2. And then type in your equals. The EE key is probably up above the 7, so if you look kind of in the line, the button's up above the 7. See if you can find it. So the answer here should end up being 400. So if you punch it in right, you get 400. Here's my other comment, that you can just like punch in scientific notation manually with your calculator. But sometimes the parentheses make a big difference. Like if I do my division, 2 times 10 to the 5th divided by 5 times 10 squared. If I were to just take my calculator and punch in 2 times 10 exponent 5 divided by 5 times 10 exponent 2, here's the mistake that the calculator is going to make. It goes through and does this in order. So it does 2 times 10 to the 5th, and then divides that by 5, and then multiplies that whole thing times the 10 squared. So instead of the 10 squared being in division, being in the denominator, it takes it out of the denominator. So if you're not going to use this EE button, because the EE button nicely puts it in parentheses, I said it does the parentheses too. If you're not going to do that, you need to put the denominator in parentheses if you're going to manually type it in. But that's the nice part about using the correct key, is it's shorter and it'll do it correctly for you. Does that make sense? Which, the last thing is about this one, I maybe should have picked something that would give you some awful answer. But if your calculator gives you something like 4.2 and then a little E on the screen and then like a, 8. What that's trying to say is it's trying to say 4.2 times 10 to the 8th. It's its way of saying scientific notation. The number's too big to fit on your calculator screen, so it'll kick over to scientific notation for you. Is that good? All right, last example, and this is worth paying attention to, because this will save you some time. So example 6, if I had a 2/5 and take this to the -2, I wouldn't write it this way, but I guess you could. This is one way to do it. The -2 applies to the 2 and to the 5, right? So I need to take the 2 and the 5 in my fraction there, in my parentheses. I need to apply a negative exponent, and I need to apply a squared to both. How a lot of people do it is they look at it this way: 2 to the -2 over 5 to the -2. And then once we're there, well, this has to flip down below because it's a negative exponent. This gets flipped up above because it's a negative exponent. So I get a 5 squared over 2 squared. You still tracking with me?
Yes.
So then I have a 25 over 4. Can't reduce it. We're done. Yes? There's nothing wrong with doing that. What'll save you a little bit of time is if instead, do you agree that -2, or the negative, is going to flip my fraction? So you could just look at this instead as being, well, that's the same as 5 over 2 squared. Which, do you agree that's 5 squared over 4? I'm sorry, 5 squared over 2 squared? So you get a 25 over 4. I think that's a whole lot easier, kind of that second way. Just, well, the negative applies to both, you just flip them, and then just do your math from there. I think that'll save you some time. I could give you more examples, or we could say, woo, we're done.